Welcome once again to the My Guru Online GRE classroom. Today we're going to take a look at a sample quantitative comparison from the exam and look at plugging in rather than overly complex algebra. As we do for all of these problems, put down the quantities first and our answer choices in the middle. And we remember that we can put our little helper symbols just to indicate what those four choices mean. And we've got, in this case, quantity A being the value of x and quantity b being the value of y. Then we'll write out y equals 2x squared plus 7x minus 3. In this case, if you look at the problem and the algebra, it looks like an incredibly complex quadratic, and it is. If we tried to factor this, it would be really difficult. If the algebra is neither apparent nor simple for a quantitative comparison, instead, plug in an easy value and then consider what we're going to call frozen. So if we wanted to just plug in an easy thing for x, we could plug in x equals, say, 2. And if that's the case, we've got 2x squared, so that would be 8, plus 14 minus 3, which means that we would end up with 19 equaling y. And in this case, with x equaling 2 and y equaling 19, when you plug in x for 2, we can see that quantity b is definitively larger. So that means that we can eliminate a and c. And no matter what, once you plug in successfully, you can eliminate at least 2 of a, b, or c every time. As for that frozen piece, this is going to be your checklist of weird values to change outcomes. So we're going to have an F, an R, an O, a Z, an E, and an N here. The F is, of course, going to be fractions, because fractions can do a lot of strange things to the math should you plug them in. The next one is probably the least dealing with math, and that's going to be repeats, and that's either going to be numbers in the problem or the same number for multiple variables. So what that means is if you had, say, x and y in this case, could they both be the same thing? Obviously, in this case, they wouldn't, because y is predicated on x. But if you had just a bunch of different variables, could they all potentially be the same thing? So you'd have, a, b, c, d, and could they all just equal, say, 5? That could potentially change the outcome of the problem. Now, the next two are going to be individual numbers that do strange stuff to the math. They're going to be 1 and 0. And then we've got extremes, and the way that you always want to consider extremes is in terms of range. And so that would be something like if there was a greater than and less than symbol, and it said that it was x somewhere between 1 and 10, I'd want to try something like 1.1 and 9.9. Get to the high end and the low end extremes of that range and see what would happen to our quantities. And then the last value here is going to be negatives, because obviously multiplying by a negative, dividing by a negative can change the sign in one potential step. So since we want to get our y to be less than our x, we want to somehow change this and mitigate the impact of that x. And in this case, a good way to do that might be by plugging in 0 for x, because if x is equal to 0, then all that's going to be left for our y conversion is going to be that negative 3, because 2x squared is going to become 0. Plus 7x is going to once again be 0, and then we've got negative 3. So in this case, x is equal to 0, and y is equal to negative 3. And of course, 0 is in fact greater than negative 3. So we cross out b and we select d confidently.